Welcome to my channel. Today, in this video, you are going to learn to write a program in Java to check whether a given number is an abundant number or not. A number is said to be an abundant number if the sum of its factors excluding the given number is greater than the input number. For example, let's take the value of n as 12. The factors of n excluding n are 1, 2, 3, 4 and 6, excluding the input number 12. Sum of its factors is equal to 16. So, sum is greater than the input number, that is 16 is greater than 12. So, we can say that 12 is an abundant number. Some of the examples for abundant numbers are 18, 20, 24, 30 and 36. Let's look at the algorithm to solve this problem. First of all, let's input the number. The second step is to initialize a variable to store the sum of its factors. At third step, take all the numbers from 1 to n minus 1, excluding n. For that, we have to use a loop. For I is equal to 1 to n minus 1. The index variable of the for loop takes the values from 1 to n minus 1. Check the divisibility of n by each value of I. If n is divisible by I, add that I to sum. I is a factor of n. Repeat through step 3 till the value of I is equal to n minus 1, including n minus 1. When the loop completes its iteration, you will have the sum of all the factors of n excluding n in sum. Now, check whether the calculated sum is greater than the value of n. If sum is greater than the value of n is an abundant number. Otherwise, n is not an abundant number. Now, let's convert the algorithm to a Java program. First of all, let's import the scanner class from Java's utility package, as we have to input the number into the program. Next, let's begin the class. Public class abundant number. The body of the class is opened. Executable statements in Java are written inside methods. So let's begin a method. Public static void check. Any name can be given to the method. In the next line, required number of variables are declared and initialized. An integer type variable n to store the input from the user, loop index variable I, and a variable called sum is declared and initialized as 0. Sum is used to store the sum of all its factors except the input number. At the next step, we have declared the scanner class object, and the scanner class object is connected to the default input device of your system. Let's give an interactive message for the user to enter the number. System.out.println enter a number. The input from the user is accepted by using nextInt method of scanner class. N is equal to sc.nextInt. Now, let's find out the factors of n and calculate the sum of all the factors excluding n. For this purpose, let's use a for loop. The for loop's index variable I takes the values from 1 to n minus 1. For I is equal to 1, I less than n. And each time when the for loop goes for the iteration, value of I is incremented by 1 to take all the values from 1 to n minus 1. Now, within the body of the for loop, we have written the statements to check the divisibility of n by each value of I, whether n is divisible by each value of I. If n is divisible by a particular value of I, that means that I is a factor of n. So, add that factor to sum. Now, let's check how this for loop works with the value of n as 12. So, here the value of n is 12. As the control comes to the for loop, the initialization statement is executed. I is initialized as 1. Now, after the initialization, control goes to the test expression to decide whether the loop has to be executed or not. Value of I is 1. 1 less than 12. Test expression is evaluated to true. So, as the condition is evaluated to true, control enters into the for loop's body. to execute the statements given inside its body. If n modulus I is equal to 0, the current value of n is 12. 12 modulus value of I is 1. 12 modulus 1 is equal to 0. Condition is evaluated. The modulus operator will divide n by I and the remainder of the division will be returned. 12 modulus 1 is equal to 0. Yes, 12 is completely divisible by 1. So 1 is a factor of 12. As the condition is evaluated to true, the statement given after the if clause will be executed. Sum is equal to sum plus I. The value of sum is 0. 0 plus 1. Value of I is added to sum. As the closing of the for loop's body is seen, control resumes to the updation statement of the for loop. Value of I is updated, incremented by 1. The current value of I is 2. After the updation statement, test expression is evaluated to decide whether the loop has to go for the next iteration. 2 less than 12. As the test expression is evaluated to true, control enters into the loop's body. At this point, 12 modulus 2 will be evaluated. 12 is completely divisible by 2. So 12 modulus 2 is equal to 0. 2 is a factor of 12. Sum is equal to sum plus the value of I. So 2 is added to sum. Now the value in sum is 3. Closing of the for loop's body. So control resumes back to the updation statement. Value of I is incremented to 3. After the updation statement, test expression is evaluated. 3 less than 12. Yes. Control again enters into the for loop's body. The if clause is executed. 12 modulus 3 is equal to 0. Yes, 12 is divisible by 3. 12 modulus 3 is equal to 0. It is evaluated to true. So 3 is a factor of 12. Sum is equal to sum plus the value of I, that is 3. Now the current value in sum is 6. Closing of the for loop's body, control resumes to the header line to update the value of I. Value of I is incremented to 4. 4 less than 12. Test expression is evaluated to true. Control enters into the for loop's body. Statement if clause is executed with the value of I as 4. 12 modulus 4 is equal to 0. Yes, 4 is a factor of 12. The remainder of the division is 0. So the test expression is evaluated to true. So the statement given after the if clause will be executed. Sum equal to sum plus I. Value of I, 4 is added to sum. Again, value of I is incremented. The value of I becomes 5. Test expression is evaluated. 5 is less than 12. 12 modulus 5 is executed. Remainder of the division is not equal to 0. So test expression is evaluated to false. 12 is not divisible by 5. So 5 will not be added to sum. Goes for the next updation. Plus plus I. Value of I is updated to 6. 6 is less than 12. Again, 12 modulus 6 is executed. 12 modulus 6 is equal to 0. 12 is divisible by 6. So test expression is evaluated to true. So as the if condition satisfies, sum equal to sum plus I will be executed. 6 is a factor of 12. 6 will be added to sum. The value in sum right now is 16. Now as the closing of the for loop's body is encountered, so control resumes back to the updation statement. Value of I is updated to 7. 7 less than 12 is evaluated. It is true. Control enters into the for loop's body. The statement given inside the for loop's body is executed. 12 modulus 7 is equal to 0. 12 is not divisible by 7. So test expression is evaluated to false. Next value of I, 8. 8 is less than 12. 12 modulus 8 is equal to 0. No. 12 is not divisible by 8. So test expression is evaluated to false. 8 will not be added to sum. Again value of I is updated. It becomes 9. 9 is less than 12. Statement 12 modulus 9 is executed. 12 is not divisible by 9. 9 is not a factor of 12. So, it will not be added to sum. Value of I is updated to 10. 10 is less than 12. Again, control enters into the for loops body. 12 modulus 10 is equal to 0. Remainder of the division is not 0. 12 is not divisible by 10 completely. So, test expression is evaluated to false. So, 10 will not be added to sum. Next updation of I as 11. 11 is less than 12. So, control again enters into the for loops body. 12 modulus 11 will be executed. 12 modulus 11 is equal to 0. 12 is not completely divisible by 11. So, this test expression is evaluated to false. Statement sum is equal to sum plus I will not be executed. Again, for loop goes for the updation statement plus I. Value of I is updated to 12. Test expression is evaluated. 12 less than 12. The test expression is evaluated to false. And now we have taken all the numbers from 1 to 11 and checked whether 12 is divisible by all these values. Whenever we found that value of I is a factor of n, we added that factor to sum. When the for loop completes all its iteration, all the factors of 12 are added to sum. Now we have the value in sum as 16. As the control came out of the for loop, when the test expression was evaluated to false, to execute the following statements given after the for loop. As we have calculated the sum of all the factors of n excluding n, now we have to check whether that sum is greater than the value of n. Sum is 16. 16 greater than the value of n, 12. Condition is evaluated to true. So, 12 is an abundant number will be displayed on the screen. Closing of the method is given and the class is closed. Thank you for watching. For more videos, like, share and subscribe my channel.